So for these problems, remember when you're trying to simplify, you want to look for squareds and ones and use your identities and replace, and usually work with sine and cosine to make sure you have no fractions. So this lights up and I know I can replace. So if I rearrange this identity, I get 1 minus cos squared equals sine squared. So I replace 1 minus cos squared with sine squared. We then want to work with sines and cosines usually. That's a good trial. So we know cosecant is 1 over sine x. So then on top, if we have sine squared, that's sine times sine, that's sine squared over sine. One sine cancels, so our final answer is sine x. So for this next problem, number 12, we first change division to multiplication and we flip the fraction on the right. So if we had 2 tans on top and 3 tans on bottom, then we're left with 1 tan on the bottom and the secants cancel. So we don't want to have a fraction, so we move the tan and the reciprocal is cotan. So we're left with 1/3 times cotan x. So for the next one, we usually want to work with the messier side. So for number 13, I chose to work with the left-hand side. So since I had one fraction and I was adding, I made the other a fraction. And then I don't see any squareds or ones, so I'm going to try to create squareds. So if I multiply the right fraction by tan x over tan x, also with addition, we're going to need a common denominator. We'll get tan squared x on top over tan x on bottom. Now we can add these two fractions because both denominators are tan x. So on top we have 1 plus tan squared x. And in the denominator we have tan x. We see ones and squared, so we can replace the 1 plus tan squared x with secant squared. And we know that if we have the top, the numerator, secant squared, divided by the denominator, tan x, we can then change to multiplication. And I usually said try to work with sine, cosine, and tan. So we move the secant to the bottom and we change it to cos because that's a reciprocal. And then we can replace tan with sine and cos because we would get stuck if we left it as tan. And we now have 1 over cos squared times 1 over sine x. But top divided by the denominator is the same as 1 times cos x over sine x. And then, so if we change the right side and we have on bottom 1 over cos squared x, we see we can cross out a cos in the numerator and denominator, so we're left with 1 cos in the denominator, and we have a sine because it's multiplication. On top we have 1, so now we match our right hand side. We're trying to prove that the right equals the left. So for number 14, I decided to work with the left-hand side. It doesn't really matter. I don't see any squareds or ones. I already have sines and cosines, so I'm going to try to create a squared on 1. So I decided to multiply top and bottom by 1 plus sine x, because then on top, when we FOIL, we'll end up with 1 minus sine squared x, and then we can do a replacement using our identities. We can replace that with cos squared. And then in the denominator, if we leave it factored at first, we can cross off a cos on top and bottom, meaning we're left with 1 on top, and we have 1 plus sine x in the denominator. We can stop there because it looks like the right-hand side. And for this next one, the left side looks messier. I see squared and 1. I like that, so I replace the denominator with secant squared. So I'm going to do the top divided by the denominator. We don't want fractions. We can replace tan with sine squared over cos squared x. We can change the division of secant squared to multiply and flip 1 over secant squared. And then we can move the secant squared to the top because of the reciprocal is cos squared. If we extend that line because it's multiplication, the cos squareds cancel and we're left with sine squared x. So for number 16, when it says solve, you first want to get all terms on one side. So we move -1 to the left. You first want to see if you can factor if possible, because I see sine squared, sine, number, constant. So I'm looking for a combo that multiplies to -2, a times c, that adds to -1. There is a combo, so it is factorable. Otherwise, we'd use the quadratic formula. So we have x minus 2, x plus 1, the factors, but then I do it by dividing by the a value, simplify, swing out. So 2 over 2, we end up with 1, so we have x minus 1, and 1/2 doesn't simplify, so the denominator swings in front of x. So now that we have our factors, just remember if you're doing it this way, put sine x back in where you have the x spot. So these are our factors. You then set each factor equal to 0 and solve. And then when we solve for the left one, we're asking ourselves as we spin around the circle, where's the sign, where's the right-hand side going to be 1? And it will be 1 up here at 90 degrees, or pi over 2. So that's one of our answers. Then for the other one, when we isolate sine x, we get a ratio of -1/2. So we're asking ourselves as we spin around the unit circle, where will we have a sine value, the right-hand side of the ordered pair, where it's -1/2, and it will be at 7 pi over 6 and 11 pi over 6. So we have 3x values for our answer. And you can see over here how I figured out where the sine would be 1/2, right? At 30 degrees, at 90 plus 60, so at 150, but neither of those work because they're positive and we want negative. So down here we have sine -1/2, sine -1/2, and we know 180 plus 30, we get us 210 degrees, which is equivalent to 7 pi over 6. You could write either. And we know that 270 plus 60 gets us 330, or you can write 11 pi over 6. So we have 3 answers. For number 17, as we get all terms on one side, just make sure that you're working with all the same value, sine, cosine, or tan. So if you're not, you might have to do a replacement first. But we don't, because they're all the same, they're all cos. So unfortunately, there's no value that multiplies to -6 that adds to -2, so we use the quadratic formula. And when we plug in to the quadratic formula, we get cos x equals 2 plus or minus squared 28. We then put in our calculator. We're going to get decimal forms. We have to consider the plus and minus, so we're going to have 2 different equations we have to consider. When we have cos x 1.823, we cross off, no ratio for cos will ever be larger than 1. And then we insert inverse cos of -0.823 into our calculator, and we will get out 145.39 degrees if our mode is in degrees. Now you want to find another value, so you're also going to do 360 minus that value we got when we plugged in our calculator, 145.39, and 180 minus 45.39. We know that we're going to go with the answer 214.61, because if cos is negative, we know that cos will be negative in quadrant 2, where the degree is 145.39. And we know that between these two answers, we know that the cos will also be negative at 214.61 degrees. If we did 180 minus 145.39, we get 34.61, which is in quadrant 1, and the cos is not negative there, so we can't include that value. So our 2 answers are right here, the angles where we have that ratio, negative 0.823, is at 145.39 and 214.61.